Hello everyone. Today I want us to look into this paper. Why this paper is important? It's important because it serves as a foundational paper in diffusers models. So what are the diffusers? Diffusers are basically this generic ability to generate images based on text, given the image, ability to modify the image, add to it, remove the background, do any kind of a transformation. And I certainly think this paper lies in its foundation. Why? Because they had this very interesting original idea of how to look at the image and be able to destroy its structure. So for instance, maybe you're looking at the image of a cat, and obviously you see its body, paws, and so on, and you add a little bit of noise and you do it systematically, and you actually destroy that image in the sense that when you look at it, you are not able to see a cat anymore. So I'm going to show you this diagram. We're still in this fashion space. So I had a dress right over here on the left hand side. I added some Gaussian noise to it, and we can still see a dress, but the quality of it is not so great anymore. Why it's important to do that? Well, it's important to do that because if you are able to add a little bit of noise like we have done over here, then you can ask neural net to actually do the reverse and go from this image to a better quality one. And if you do it systematically, then a model would learn, or a piece of software will actually learn how to go from random noise to high quality image. So essentially it would start generating high quality images based on prompt or based on underlying image and so on. So since we're going a little bit more technical today, I'm going to show to you how to add noise to an image. And there's just like basically 10 lines of code, and you're able to do that. So this piece of code with a little bit of adding Gaussian noise to it will result in this image. Okay, so it's super simple, not a lot of work. So let's take a look at this paper again. So important things to notice are basically we're doing this systematic addition of noise in a Markov chain fashion. So what is important is at time t, we're only looking at the prior step at time t minus 1. And if we would able to do that systematically and the interval is small enough, then we would be able to do the reverse. So actually going from the bad quality of image to a good one. And of course, they have more theory behind the scenes. You also see the flashy names, right? So it's super influential, important paper to take a look. Another thing that I really want to point your attention is this. It's a central limit theorem. This is kind of a backbone of a lot of diffusers and a lot of models, statistical actually models in general. And what is the important point is that when we start with a distribution that is not normal, you see two bumps over here. When you have a random noise, then you can't even detect what kind of a function is it. It's pretty much like probably uniform distribution. But if you take sample from that not normal distribution, central limit tells you that given enough samples, you will get to normal distribution. So this is kind of the core of a central limit theorem, and we're able to leverage that result in many different ways. All right, so that's pretty much what I wanted to cover today. If you have some time, please take a look at this paper. There is so much information nowadays available, and I think it makes sense for all of us to leverage that information. Also, at the end, you can go to Stable Diffusion and you can play around, right? Before actually maybe even launching code and generating anything, you can check out Stability AI, Stable Diffusion model for free. You can spin the Dream Studio, or you can start writing code yourself, and go from there. Thank you so much. See you next time.